In this problem, we're given this geometric shape. This curve right here is defined by the function y equals to x to the third power, and we need to determine the centroid location of this area. We know how to write down the formula x bar equals to the integration of x tutor dA area divided by the total integration of the area, and y bar equals to y tutor dA integrated throughout the area, and then its total area. X tutor and y tutor are the coordinates of the centroid of the differential element. Therefore, if, for example, I pick my differential element to be this little square right here at arbitrary location x and y, so this point has coordinate x and y, then for this differential element, its centroid location, so x tutor and y tutor, simply equals to x and y. And its width along this direction is dx, along this direction its height is dy, therefore its area equals to dx times dy. However, if we choose this to be the differential element, then we will have to integrate with respect to two variables, which is more difficult. Therefore, we are going to not choose this as our differential element, but instead choose a strip. It could either be an horizontal strip or a vertical strip. So if we choose a horizontal strip, then this right here is going to be x, and then from here to here is going to be dy. Or if we choose a vertical strip, that in that case, this total height right here actually equals to 1 minus y, because this location is y. And then its width right here equals to dx. So either way, if you choose a strip to be your differential element, you only need to integrate with respect to one variable. So that's what I'm going to do. While I can choose either the horizontal or the vertical strip, I'm going to choose the horizontal one for this problem, just so that I don't like to deal with the 1 minus y in the vertical strip. So this is my differential element. It's a rectangle, therefore its centroid location is easy to find. It's right there in the geometric center right here. Therefore, this point has coordinates of x and y, which means that from here to here, this total width is x. This height is dy. The centroid has coordinates of 1/2 x. Because the total width is x, therefore the centroid is right there at the center. That's 1/2 x. And the y coordinate is simply y. In other words, x tutor equals to 1/2 x, y tutor equals to y. dA equals to the area of this rectangle, the width x times dy, which is the height. So now we're ready. We can integrate dA throughout this entire area, and that equals to x times dy. And we're going to represent x as a function of y. If y equals to x to the third power, then x equals to y to the 1/3 power, cubic root of y, times dy. And now we can integrate it with respect to y, and y varies from y equals to 0 to y equals to 1. So that is integrating throughout the entire area. And this is not difficult to do. This equals to 3/4 times y to the 4/3 power, evaluated from y equals to 0 to y equals to 1. So this eventually equals to 3/4. And this is actually the total area of this, this shaded area. So that's the denominator in our two centroid coordinate equations. So to calculate x bar, we need to integrate x tutor dA. and x tutor equals to x over 2, dA equals to x dy, and don't forget x equals to y to the 1/3 power. So again, y equals to x to the 3rd power, therefore x equals to y to the 1/3 power. So we have x to the 2nd power, therefore this equals to 1/2 y raised to the 2/3 power dy, again integrated from 0 to 1. This equals to 1/2 times 3 over 5 y raised to the 5 over 3/3 power, evaluated from 0 to 1, and that simply equals to 3 over 10. Therefore, x bar equals to this right here, 3 over 10, divided by the total area, this right here, 3 over 4. This equals to 4 over 10, which is 0.4 in the unit of meter. Similarly, we need to integrate y tutor dA. And y tutor simply equals to y. dA is x dy. Again, x is y to the 1/3 power multiplied by another y. So this is y raised to the 4/3 power. If integrated from 0 to 1, this equals to 3 over 7 times y to the 7/3 power, evaluated from 0 to 1. And this simply equals to 3 over 7. Therefore, y bar equals to this right here, 3 over 7, divided by the total area again, so that's 3 over 4, and that equals to 4 over 7, and we can evaluate it to be 0.571 meter. So that's the final answer. So x bar y bar equals to 0.571 meter. So that's the location for the centroid of this shaded area. So it doesn't hurt to double check it. So again, from here to here is 1 meter. So x bar equals to 0.4 meters. So it's a little bit to the left of the center. Y bar is 0.571 meter, which is a little bit above. So the centroid location is approximately here. So that looks about right. So this is a reasonable result for the centroid location.